All right, this is section 7.5. We're just finishing up the last piece of this unit of chapters 6 and 7. And look how nice I am. 4 problems. Holy moly. What was I thinking? That's all right. You guys deserve a break. Okay, so what is this? Well, it's a complex fraction. Why is it a complex fraction? Well, these are even more complex because this complex is not like the complex number system where you have the imaginaries. It just means it's got a lot going on. All right. So what I want to show you is that these things are not, they look bad, but they're not if you rewrite them. So if I would have 1/2 divided by, I don't know, 5/7, I can write fractions that way. But this is the exact same problem. And I think I already showed you this. Right? These are equivalent. It's 1/2 divided by 5/7. So whenever you have something that looks like this, I guess my suggestion to you, why am I moving this? I don't know. My suggestion to you would be to, I'm just trying to get it so I can see that whole thing, would be to rewrite it so it doesn't look so bad. Divided by 3r over t, right? Those are equivalent statements. And now we're back to how do we divide fractions? Well, we divide fractions by leaving the front one or the top one alone, multiplying by the reciprocal of the back one. Right? Now we have multiplication. We've got an r and a t. We've got a 3, an r, and a t. Now, why did I do that? Well, usually your coefficient, your constant, goes first. And then I'll go in alphabetical order, just because my math lab likes that. And I like it too. I don't know why. It just looks weird when I have t3r. Now, since I have products, everything's multiplied, right? Now I can start canceling. Everything left on the top, so we've got a 1, and then we've got the 3 underneath. So we've got a third. Should we try it? Fantastic. Okay, type an integer or a simplified fraction. If this could be reduced further, that's what it wants. All right, let's try another one. These are going to go really fast. I like that. Divided by x over x squared plus 7 is equivalent to, see, then they don't look so bad, do they? Which is equivalent to leaving the first one alone and multiplying by the reciprocal of this one. Okay? Let's put parentheses around all this stuff to remind ourselves that we're not going to go on the inside. We're going to cancel whole sets of parentheses that match. I have a 6 left on the top, and I've got an x underneath. Bing, bada, boom. Done. Okay, so these last two aren't quite so easy because here we have addition and subtraction. Okay, so we have this over this. Okay, so before I do anything, before I start flipping and doing all that kind of stuff, because that's going to be a nightmare, I want to make it look like this, where look at the difference here between numbers 2 and 3. Here I have a solid fraction divided by a solid fraction, right? Same with number 1. Solid fraction divided by a solid fraction. Number 3, I have a fraction plus another fraction divided by a fraction minus another fraction. So I want to, my first step is to get this into one fraction and this into one fraction. Then I proceed like I have been. Okay, so I'm going to have to do some side work here. All right, so let's just work with this numerator? Okay, well, I've got different denominators. Therefore, I have to find the LCD, right? So I'm going to list my factors. Now these are factored. I can't factor them any further, so I see 4's and x's and y's. Now I'm going to go into how many times do they appear the most. Well, each one appears once, so I'm going to pick 4xy for my LCD. Okay? Now I'm going to have to turn both of these into a 4xy. So here, we're building these up again. What is that missing to make it look like that? It's missing the y, isn't it? Now they're exactly the same. Top and bottom have to have the same thing. Y divided by y is 1. So this is equivalent to that. And now we'll do it again. No, that was not supposed to be a 4. That was supposed to be a y. I'm going to build this one up. This into that. It's missing the 4x, isn't it? Oh, my dogs. I tell you what, can you hear them barking? 4 times 4 is 16x. I have to go out there and kick some butt. I have a 200-pound male 5-year-old St. Bernard and a 3-month-old, well, he's probably 4 months by now, 4-month-old male 35-pound St. Bernard. And the little one picks on the big one, and the little one wins. I'm not sure how that works. I mean, the other one outweighs him by I don't even know what. It's crazy. And yet he's just a shark. He's out there just chewing on his ears. It's just really kind of sad. So that's what they're barking about. It's the big one barking. Okay, sorry. Just wanted to explain what all the commotion was. Where am I? I have no idea. All right, I've turned this one into this, and I've turned this one into that. So now I can add them. So we have 9 over 4x plus 4 over y is the same as, instead of this one, I'm going to use that one, 9y over 4xy plus, instead of this one, I'm going to use that one, 16x over 4xy. Okay, now I have common denominators. Can carry that across, and it's telling me to take 9y plus 16x. Do you see how I've turned 2 separate fractions into one solid fraction? That's my goal. I have to do it again. Now I got to work on this one. Oh, dog. Okay, hang on, I'll be right back. I got to go fix that. All right, sorry about that. Gave them each a bone. Then, of course, they start fighting over the same bone. Even though I gave them the 2, they each have to have that one. So if they're barking again, I'm going to, I don't know what. All right, where was I? Oh, we had to do the same thing with this bottom one. We didn't even do anything on that one, right? No, okay. So let's subtract these. I need an LCD. I have to list my factors. I see 4's, x's, and y's. I see one of each. So again, my LCD is 4xy. All right, I have to turn each one of these into 4xy's. So we have 4y, and we need to turn that into a 4xy. So what is this one missing to make it look like that? It's missing the 4x. Multiplying straight across gives 16x. Do it again with that one. Now we have 9 over 4x. I want to turn that into 4xy's. What's this one missing to make it look like that? The y. Multiplying straight across. So now, instead of writing this minus that, I'm going to write this minus that. Okay? So now I have, this is a long problem, holy moly, 16x over 4xy minus 9y over 4xy. I have a common denominator of 4xy, and I'm going to take 16x minus 9y. Okay, so that's my denominator. So this piece of it here is my denominator all in one fraction. And this up here was my numerator all in one fraction. So now I'm going to take my numerator and divide it by my denominator, but I'm going to write them this way. So I have, boy, it's going to be hard to do this without, okay, so I have 9y plus 16x over 4xy. Is that what I had up there? 9y plus 16x over 4xy. And I'm going to divide that by my denominator. I'm going to write them side by side rather than up and down. 16x minus 9y over 4xy. I want to get rid of my division, so I want to multiply by the reciprocal. Why did I write that? Okay, I'm just going to flip this one upside down. Nice arrow. I'm going to put parentheses around everything so that I am reminded not to go on the inside of these things. What's left is a 9y plus 16 over 16x. I lost my x somehow. How did I lose my x? I don't know. I forgot to write that x here. So I've got an x here. Over 16x minus 9y. Okay, that's as good as it gets. Should we try that one? Maybe we should. 9y plus 16x divided by 16x minus 9y. Check answer. Good job. Look at all these steps, you guys. All of this. Well, no, not this. Right here, starting here. Look at all these steps. We had to first of all get the numerator into one solid fraction. We had to find an LCD and add them. Then we had to do it again for the denominator. We had to find, an LCD and add them so I can get it into one solid fraction down here. Then I had to divide, change it over to multiplication, and cancel. Now these can't be canceled further, right? They don't match. This is a positive 9 and a negative 9, so these don't match. And I'm never going to go on the inside of these things and start hacking away. Otherwise you'll have to answer to me. Haha. Okay, so that's finished. Let's see what, okay, same thing here. Nothing's new, but I still think we should do it just because we probably need the practice, huh? Yeah. If, let's just say that you feel comfortable with what we've done so far, then don't watch the rest of us. And then if you have trouble, then you watch it. You can always, I'm not looking to see who's watching and how long you're watching. So, that's your personal preference. That's something that you have to, figure out how much of this you need. This is exactly what I'd be doing in class. The only difference is that, I'd have more questions right then and there. Like, why are you doing that? Why are you doing this kind of stuff? Okay? But otherwise, it's exactly, I would do the same thing in class. So, all right. So So what do we have? We have a fraction plus a fraction over a fraction minus a fraction. So we've got to get these into one solid fraction again. I've got to work on the numerator and then I've got to work on the denominator. So I will get these filled in later. Okay, so I'm just going to start over here. So I'm going to add 1 over m plus 4 plus 1 over m plus 5. Okay, different denominators, need a common denominator. My factors that I see are m plus 4s, m plus 5s. I need one of each. They appear at most once in either one of these. So I'm going to convert them over. So I've got m plus 4. I need to turn that into an m plus 4 times m plus 5. This is missing this piece. So that's what goes here, so they match top and bottom. 1 times anything is itself. Okay? Do you see how that turned into a solid fraction? Although it's messy, it's still a 1 fraction. Okay? I'm going to do it again with the 1 over m plus 5. Turn that into m plus 4, m plus 5. This one is missing this piece. M plus 4, top and bottom. 1 times anything is itself. See, now if I was to reduce this down, I would get 1 over m plus 4. Or if I was to reduce this down, I get 1 over m plus 5. So what I'm doing is I'm building them up. Okay? So now I'm going to add these, but I'm going to add these. Right? So here I have m plus 5, m plus 4, m plus 5, plus m plus 4 over m plus 4, m plus 5. Okay, this is equivalent to that, and this is equivalent to that, so I'm going to add these two, which are right down here. I have a common denominator of an m plus 4, m plus 5. You see how I'm turning it into one solid fraction again. And I've got m plus 4 plus m plus 5 plus m plus 4. So I have m plus 5 plus m plus 4. Well, this can be messed with a little bit. You know, I don't need these parentheses because I've got an addition here, but I do have two m's. I can add those two. And I've got a positive 5 and a positive 4. So there's my, what was this? The numerator. Okay? 2m plus 9. And what I want is for these two to turn into 1, which I just did. All right, now I gotta do it again. I gotta subtract these two. All right, now what's gonna, look at the difference between this top and this bottom, right? I'm gonna build these up exactly the same way, except this is just gonna be a subtraction between them, isn't it? So if that turned into a subtraction, I don't want to redo all that work. It's all the same stuff. They're the same fractions, it's just a subtraction between them. So I'll pick it up from this spot. All right. Common denominator of an m plus 4, m plus 5. Boy, skip steps where you can, huh? And I've got m plus 5 minus m plus 4, the whole quantity. So here, because it was a plus, I didn't need to distribute a 1 through, but here I do need to distribute this negative 1 through. Okay? So on the top, I'm going to have to do a little bit of work up here. I've got a minus m, that's a negative 1 times an m, and then a negative 1 times a 4 is minus 4. And then I've got this. Okay. Now I'm going to combine like terms. I've got m minus m for 0 m's, and I've got 5 minus 4 for 1. And this is my denominator. That goes up here. All right, so now I have a solid fraction over divided by another solid fraction. So what I'm going to do is I'm going to leave my front one alone, my 2m plus 9 over m plus 4 m plus 5, and I'm going to multiply by the reciprocal of this. M plus 4 over m plus 5, because remember that's how we divide fractions, is we multiply by the reciprocal. And now I'm free to throw all this into one big fraction because that's how multiplication works, right? I can just squish it all together. And now I'm canceling entire sets with entire sets. All that's left is a 2m and a 9 plus 9. That's a plus. 2m plus 9. All right? So this is the simplified version of all of that. Okay? That's it. That is as far as we can go with these. Well, no, it's not, but obviously we can go a lot farther with these, but I've only chosen these 4 problems because I don't want to stress you out. Sometimes these can really be bad for some people. So I've taken 4 fairly simple ones. You know, your addition, subtraction pieces are fairly mild. They're not, you know, too hard for finding LCDs and stuff like that. But again, look at all these steps. You know, there's a lot of steps and a lot of room for error, so you have to be really careful with this kind of stuff. You know, check and recheck, go backwards wherever you can. And that's it. Okay, so that's it for chapters 6 and 7. So, excuse me, when you're done with this, you know, make sure you get the review problems in. I've split 6 and 7 into 2 separate review problems. Take the quiz. You know, practice, practice, practice. This stuff is not easy. This is not an easy course, especially online. This is not an easy course. So, you know, practice. Ask questions. Use a tutoring center. You know, read the book. Reread the book. Watch the videos. Re-watch the videos. Work problems and rework the problems. See, why did I do this on this problem? Why didn't I do that on that kind of problem? What are the differences between those two? That kind of stuff, you know. It's very hard. Make sure that you understand the difference between GCFs and LCMs. Not much different, but they're completely different in another way. The methods are very similar, but they're not. Sometimes that's really a tough thing for a lot of people, is if the methods are too similar, they get them mixed up. So be careful. And then finally, you know, you can always ask me questions if you ever need to meet with me. Just shoot me an email and I can come on campus and meet with you. I hope some of you are using the tutoring center. Boy, that's a great spot. It's free and they're good. And you can pull up your My Math Lab homework right there and they can help you. So you've got lots of resources. I hope you're using them. So I will see you for chapter 10. We're going to move back into the back part of chapter 10 next. That'll be a nice quick bing bada boom in and out. We've only got 3 sections, and then we'll move on to chapter 11, which I believe is logarithms. So I'll see you then.